Question number 10 is trigonometry 3D. So we have a pyramid. The information is given. So the base is a square and every other slant lines are all equal like always is. So question number A. So find the height of the pyramid. So the right angle triangle that we use for the height of the pyramid will be this one is the height of the pyramid we have to find, and we need to know the diagonal of the base. So this is a right angle triangle. So let me call this X. So triangle VXC. If I draw a miniature triangle over here, so this triangle would give us the height of the triangle, a height of the pyramid VXC. The only thing we know right now is that slant line is 18. That's all that we know. So we have to find this AC, half of AC, this one. So we have to draw another miniature triangle, which is the floor. The floor is a square. So if this is 10, this is 10. If this is A, this is C, and this is going to be half of AC. This point is going to be the midpoint of this diagonal. So let's find this. So in triangle A, this is B. So ABC. So ABC, using Pythagorean Theorem, I can say AC squared equals to 10 squared plus 10 squared. So 100 plus 100 is 200. So therefore AC is square root of 200. Length cannot be negative. So therefore half of that is going to be XC is going to be root over 200 divided by 2. So now we can get back to the height of the pyramid. So in triangle VXC, I'm leaving it this way so that there is no rounding of error, otherwise we have to take some more decimal places. So the hypotenuse is 18 squared. The height that we have to find is Vx whole squared. Thus this Cx is going to be square root of 200 by 2 whole squared. That turns out to be, so 18 squared is 324. 324 minus square root of 200 whole square is 200. 2 square is 4. So this is Vx squared. So therefore Vx equals to, so this would be minus 200 divided by 4 is 50. So square root of 274. So square root of 274, and that is square root of 274 is 16.6. So 16.6, the unit has to be in centimeter. The reason I'm just writing this off, because if I have to use Vx for another sum, I'm just going to use square root of 274. So I don't have to bother about this being very accurate. So question number B. Question number B is the angle between VA and the base. So the angle between VA is this slant line and the base is this ABCD. So that angle is going to be like this. So if this is the base and this is the angle, this is VA, so we just need this diagonal over here, and this is the angle we're looking for, this particular angle, and we already found the height Vx. So the triangle is going to be VAX. So we can use the same triangle here, the same triangle, or we can use a different triangle, because this C over here and that A over there is going to be the same, so it doesn't really matter. So question number B. So in triangle VXA, you have to find this angle. So tan, so you have to show this miniature triangle like this. So VXA, this is our theta. So tan theta equals to opposite. So Vx, we just found Vx as exact value is square root of 274 divided by base. Base is half of what we found, that is square root of 200 by 2. So square root of 200 by 2, that should give us the exact value. So let's use the calculator. So square root of 274 equals to this, divided by, let me use a bracket here. So square root of 200 divided by 2, and that turns out to be 2.34. So tan inverse of that, this is the radian mode I did before, so let me convert this. That's a problem if you forget to convert it to degree. Okay, so let's try this again. So square root of 274 equals to this, divided by, bracket open, so square root of 200. Let me use this in a bracket so that the calculator doesn't misunderstand with this thing. Then we have divided by 2, bracket close. So we have this 2.3409. 2.3409. So therefore theta equals to tan inverse of 2.3409, and that turns out to be, so tan inverse of this, so it is 66.869. So 66.869 degrees. So answer, VA makes 66.9 degree with the, what was the exact format of the question? With the plane, with ABCD. ABCD, that's it. So question number C. Question number C, find to this another angle, the size of the angle between the plane VAB. So now this time it has to be the plane VAB and the ground. Okay, so if I take this all over again, this ABCD, and the plane VAB is this. This is V, this is A, this is B. So the angle is going to be, you take one here through the middle, and you take here, and this is the angle this time. This is the rule for angle between plane and plane. And the height we already know is X. So this time the triangle, let me call this Y. So this time the triangle we can use here is this one. So V, this is X, this is Y. Now, you know, every side is 10. So if you take this side, this is going to be the middle. So half of 10 is 5. And we know the height from the previous sum. It is square root of 200. This is the height is square root of 274. So if you're looking for this angle, so we can write in triangle VXY. If you can draw the miniature triangle, it doesn't matter what you label it. So this is again going to be tan. Since we have used theta, it's not a good idea to use the same angle over and over again. We can either use the name VYX, or we can just call it alpha. So tan alpha equals to, opposite is 274 square root divided by 5. Therefore alpha equals to tan inverse of square root of 274 divided by 5, and it turns out to be, so tan inverse of square root of 274 divided by 5, and the angle is going to be 73.192. So 73.192. The answer has to be in three-digit figure. So answer should be VAB makes 73.2 degree with ABCD. So that's it. Now the next one is, find in centimeter the length of the perpendicular from B to VA. B to VA. Okay, this is a common question from area sum, where you have to find the perpendicular distance. This is how it is usually done. So when you have a triangle like this, so this is V, this is A, this is B. Okay, so you know the slants, this is 18, you know this is 18, and you know this is 10, because the sides of the base, it's a square. So VAB is like this. So this is 18, this side is also 18, this is 10. Now for finding the height of the perpendicular, the height of the from B to this, from this point B to this, so this is the height that needs to be found. So find the length of the perpendicular from B to VA. Okay, for this we can write area of triangle VAB equals to half into base. Here, if this is the height, the base has to be 18, and the height we have to find. This is the perpendicular height that we have to find. So in order to find the height, we need to know the area of triangle VAB. Now for that, we need to find the area in some other way. This can be done by thinking of this triangle as isosceles triangle. After all, it is an isosceles triangle, and finding the height and then finding the area in another way. So let me do this. Let me do this miniature triangle over here. So if this is V, if this is B, let me call this Z since I've already used X and Y. So this is going to be 5, and VB is 18, I know. So by Pythagorean theorem, so in triangle VZB, by Pythagorean theorem, I can find the VZ. So this is 18 square hypotenuse equals to 5 squared plus VZ squared plus VZ squared. So plus VZ squared. So this is going to be 18 squared minus 5 squared equals to VZ squared. Therefore, VZ equals to, so 18 squared minus 5 squared is 25. Turns out to be 299. So this would be square root of 299. So therefore, area of triangle VAB using this height VZ, like using this height, it is half into base. This time the base is 10 and the height is square root of 299. Hence, so if you cancel this, 5 to the 10. So 5 square root of 299 is the area of this triangle. Let me put it here. And this is half into 18. 18 is 9 into h. So the height is going to be, now we can use the calculator. So 5 into square root of 299 divided by 9, which would be 9.606. So 9.606. So 9.606. So therefore, h equals to 9.61 centimeters. So that's it. That's the perpendicular height. That's how we find it. Okay, the final one. So the final one is find the size of the angle between the plane VAB, so VAB, and the plane VAD. So we have this VAD on this side and VAB on this side. So we have to find the angle between these two planes. So usually what happens, the sums are interconnected. That's how they make the sum. So if I draw this over here, so E, so this is VAB, this is VAB, and this is the other one, VAC, VAD. Let me check. VAD, yes. So now the angle that we have to find here is from here. Now we cannot find exactly from the middle because in the previous sum we found the height. So this was the 90 degree what we found. So this should also be exactly the same, and this is the angle that we are looking for. Remember, if you think of these triangles separately, they are exactly the same. This is V, this is A, this is B. So this side is 18, this side is 18, and this side is 10. Now if I draw here, this is V, this is A, and this is D. This side is 18, this side is 18, and this side is 10. So that means the height from here to here and the height from here to here, it's exactly the same which we found in the previous sum. That's why the story is linked, which is 9.606. That's the height that we found. So now the angle that we're going to find from here, if I draw the miniature triangle now, it should be like this. This side, and this side. So let me call this W over here where they meet. So this is D, this is B, and this side is the perpendicular height. So 9.606, and this is also 9.606, and BD is going to be the diagonal which we already found, the same as AC. So the diagonal is square root of 200. So this is going to be square root of 200. So the angle that we have to find is this one. Now we can easily find this. Now this is going to be double this if we do this like this. So it is going to be this angle times 2. So since it's an isosceles triangle, we can find this angle. So let me name this again. So this is W, this is D. So I can call this, we have used X, Y, Z. So W, we can call this U. Okay, so this length is going to be 9.606, and this length is going to be square root of 200 divided by 2. Half of this, it's an isosceles triangle. Let's mention the triangle. So in triangle WUD, we are looking for this angle over here. Let me call this beta. We have already called one angle alpha. So this is going to be tan beta equals to opposite square root of 200 by 2 divided by opposite by hypotenuse is sine. So this is going to be sine beta. This equals to 9.606. Therefore, beta equals to sine inverse of, so square root of 200 divided by 2 divided by 9.606, and we get 0.7361. 0.7361. So we get sine inverse of that is 47.4. 47.4. So the answer would be the angle is 2 into 47.4, because the angle we're looking for is double. So into 2, that makes it 94.8. Since this is the last, we can directly write down the answer. So 94.8 degree is the answer.